Welcome back. Here we are again, another video, sine, cosine, waves, oscillation. This is where I left off. I'm graphing the sine function in P5GS with a lot of dots oscillating up and down. I want to get to the point where I can have an additive wave, like sum a bunch of different waves together to get a more variable pattern. To do that, I think I really first want to take this example and make it object-oriented. I want to define the idea of a wave class. And the wave class itself would have just three properties: amplitude, period, and phase. Meaning, whatever these values are would translate into a wave that maybe looks like this, or one that looks like this. And then the idea being, if I could add them together, I might get something that looks something like this, not drawn precisely. There is another aspect here that I think I need to take a minute to look at. I've been really informal, mostly, about the way I'm sort of thinking about period or frequency. I've just had this idea of an angle, and then we'll increment the angle by some amount. If that number is really small, the oscillation is going to be slow. If that number is really high, it's going to be fast. You know, that's a longer period, lower period. It doesn't have to be exact about it. I just want things to be able to dial things up and dial things down. However, if I want to think about the fact that I have a canvas and I have this x-axis, what if I want to just take any given point along the x-axis and get the corresponding y value, knowing what the amplitude, period, and phase are? So there is actually a very specific formula that I can use that ties directly to amplitude, period, and phase. And maybe I shouldn't start with this, but I think going through this will really allow us to sink our teeth into waves and hopefully unlock a lot of creative possibilities for you that you might make following these sets of examples. So let's consider a specific scenario. So I have a P5 canvas. We'll say that the width is 600. And I want the period to be of the particular wave that I'm going to create to be 600. I want the full pattern to exist from the full width, the one cycle through the wave to be the width of the canvas. Let's say I want the amplitude to be 100. Maybe the height of this canvas is 200. So 0 is up here, 200 is here. So we've got an amplitude of 100 in both directions. So y for any given x is going to be sine of something. The easy part here is probably times amplitude. And actually, I know for a fact that I'm going to need a lot of space in between these parentheses, so I'm going to redraw the way I'm doing that. Whatever comes out of the sine function is always going to be a value between -1 and 1. So whatever the amplitude is, all you need to do is take this -1 and 1 range and multiply it by that amplitude. That's going to stretch it out. Of course, I could use the map function, but just demonstrating a few different ways of doing the same thing. Now, this particular scenario, the period is 600, meaning I want to see one full cycle of the wave all the way from pixel 0 to pixel 600. Basically, the x value that I'm graphing here is some part of the way along through the full period, and the full period manifests itself between 0 and 2 pi. So the formula for that, let me just write it out. I'm going to basically say, I'm going to write it out using P5 constants, 2 pi times, this is a times here, x divided by period. This is getting me to say, like, think about it. If x is 0, 0 divided by 600 is 0, sine of 0. If x is 600, 600 divided by 600 is 1, so I'm taking sine of 2 pi. So this allows me to, and given any x, find the particular y value of the function given with a given period, and then multiplying the result of that by the amplitude. Now the phase I didn't include here. The phase is just a little bit of an offset. If I wanted the wave to start here, this is maybe the equivalent of like pi divided by 2, right? If the full width is 2 pi, I wanted that to be where the 0 value, then I just need to shift everything over. So that's actually really easy because I can just add that in here. Phase plus. Let's see if I can write this out with enough space. There, this is the full formula. Let's see if we can go back now to this code and rewrite the exact same thing but with an object, a class, wave, with an amplitude, period, and phase. All right, I've taken the liberty of creating a sketch that has a wave class in it with 3 properties: amplitude, period, and phase. So I'm going to make one wave with an amplitude of 200, a period of 600, measured in pixels, and no phase, no offset. Now I should be able to write a loop to look at every x position from left to right. I'll space each one out by 10 pixels. I then want to get the y position by saying wave dot, aha, I need another function. So what should this function be called? Now I'm tempted to call this function f, and basically it's going to return the result. But this is very like a very mathy way of doing it. I think I'll just call this calculate right now. So I'm going to call this calculate. So I'm going to say y equals wave dot calculate the y value according to the x value. And what will that be? Well, now I've just got to go ahead and use that formula. Oh, it's not up there. That formula that I have over here, right? I want to say return sine of this dot phase x divided by this dot period times this dot amplitude. Okay, so take a look at this. This is exactly the formula I worked out on the board over there. Now I should be able to just draw a circle at that x position that I'm in the loop and the y position that I calculated. Let's see what I get. Something. Well, first of all, I should make these size 10 since that's the space. And then this isn't exactly right. What is wrong here? Oh, I forgot a really crucial element here, right? I'm trying to figure out where is x along the path, so to speak, of that full period. And then I need to multiply that by 2 pi, because 2 pi is the angle that goes into the sine function that gets me all the way through the cycle of the wave. So this has to be even longer. This needs to say 2 pi times x. And there we go. Now it's in the wrong place. This is because in some of my previous examples I had translated the origin to the center. I think I can skip doing that here and just add some offsets here. So for example, I know this should be plus height divided by 2. I should just move all the y values down a bit, and we can see, there we go. I've got essentially what I had duplicated now from the previous example, but I have it as an object, which is really quite powerful because now I can start doing things like, oh, let me change the period to 300. Let me change the amplitude to 50. Let me make the offset 10. Right? So all of these properties change the way the wave is visualized. And ultimately, maybe I actually would want to take this loop, which is drawing it, and make that a function inside the object itself. So maybe a wave can render itself. But I'm going to do something a little bit different here because I want to take multiple waves and add them together. So let's turn waves into an array. I'm going to start with arbitrarily just 5 different waves. And I'm going to make them all random. A random amplitude between 20 and 80. And a random period between 100 and 600. And a random offset between 0 and 2 pi. Now that I have it as an array, let's see if I can draw all of them. And I'm going to use an enhanced for loop. I'm just going to say let wave of waves. And this will do exactly this for all of them. So you can see there are all the waves. And let me say no stroke. Every time I run it, I get several different wave patterns. It's sort of interesting to see them all just overlaid on each other. What I was intending to do was say let y, to add them together, was say let y equals 0, and then y plus equal whatever that wave's value is, and then draw the result here. So this is now, every time I run this, this is 5 random waves added together. And you can see this is starting to look quite a bit more like this example here. The only difference is this is not in motion. So how would I get this to be in motion? That's a good one. There's a few different ways I could probably approach this, but for me, I think the variable for me to play with, to tinker with, is that phase of each wave. Because right now, I'm not panning across the wave. I'm not seeing anything oscillate up and down because I am looking at all of the waves with a fixed phase. They're all starting and stopping at the same place in the canvas. Earlier when I was working on this, I made a very big mistake and updated the phase in here, but I don't want to do that because this is happening, remember, for every x location so many, many times. I need a separate for loop that I'll just do afterwards. And here I can update the phase. And again, maybe this should be a function in the wave class itself, but I'm just going to very slowly just say phase plus equals 0.1. And now we can see, there we go. So now I've got essentially that example from before. I kind of want to draw these a little bit bigger to have a little bit more overlapping. I could use alpha, I could start to connect them and color, but you get the idea. Thanks to some folks who are tuning in while I'm recording this video, I've got two excellent suggestions. One is probably a better way to name this function is with evaluate. So I'm going to say evaluate. And just change that here. And then really this, I agree, this is really bothering me. I'm going to add a function called update where the phase changes by some arbitrary amount. And you can see this is just setting me up for success later, where there might be more things that I want to do to update the wave, more logic, a variable behind what it increments by. So I think the less that the wave itself is manipulated out here in the draw loop, the more that functions are added to do that, the better. Okay, so this really wraps up this example. I think it's quite close to what I demonstrated when I started this sort of set of videos. And I think there's a lot of creative possibilities. How can you visualize this using color, playing with how you orient this wave pattern, how you interact with it. There's lots of possible things that I think you can explore, and I hope you try to do those things. But there's still a couple more videos that I want to make. I'm going to make those as coding challenge videos in that they're going to be little sort of mini projects. There'll be case studies in techniques that really build on top of all of this trigonometry and oscillating motion stuff. So I want to look at coding a pendulum simulation as well as coding a spring force, a bouncing spring simulation. And both of those will really be videos that I think take all of the concepts from chapters 1 and 2, vectors and forces, and kind of combine those with the techniques that build up, that require angles and trigonometry here in these chapter 3 videos. So they'll appear in this playlist if you happen to be in the Nature of Code playlist. There'll also be standalone videos that you can find elsewhere. But this might be a moment, if you want, to sort of wrap up and stop chapter 3 and explore your own exercise, your own creative visualization of wave patterns and oscillating motion. Thanks. I hope you enjoyed these. I can't wait to see what kind of beautiful patterns people make. I'll include some links in this video's description to some creative other projects that make use of this kind of oscillating motion, and I will see you in chapter 4 or in the coding challenges or somewhere. Goodbye. Mwah.